Our lesson today is about trigonometric identities. In this video, we're going to start with a brief discussion of what identities are, and then we're going to get into what trigonometric identities are and the first of two things that we can do with them. But as always, before we get started, let's go ahead and take a deep breath. And let's begin. So first, I would ask that you recall what an identity is. An identity is effectively an equation that is true for all values of the input where both sides are defined. And just to be clear, some equations that we see, y equals 3x plus 4, this is not an identity because there are plenty of things that I could plug in for x and y that don't make this true. If I made y 5 and x 6, right, I'd have 5 equals 22, which is clearly not true. This is not an identity. Okay? I think one of the earliest identities that you guys have come encounter with is actually like the difference of squares. A squared minus b squared equals a plus b times a minus b. It doesn't matter what I plug in for a and b. I can plug in anything I want for a and b. As long as it allows the sides to be defined, this will always equal this. And what's special about identities is if you have an identity, it means that anytime you see one of these things, you are allowed to replace it with the other one. It doesn't mean you always want to, but it means you always have that option. And so identities really give us a lot of flexibility in the ways that we express ourselves mathematically. So again, difference of squares is an example of an identity. It's not a trig identity, but it is an identity. So I wanted to make sure that I had expressed this before we talked about trig identities, because you guys have seen identities before. You've used identities before. We're now just going to be extending that knowledge into the field of trigonometry. So between what we learned last year and the studies of trigonometry that we've done so far this year, we know of at least 5 trig identities. You may know more based on your own studies, your own mathematical history, but the 5 that I expect that you already know about are the tangent identity, the tangent x is sine x over cosine x, the Pythagorean identity, which says that sine squared x plus cosine squared x equals 1. And remember, that one is basically, it's effectively based on the unit circle. If you imagine the unit circle has a radius of 1, and you imagine that sine is the y component and cosine is the x component of whatever angle you choose, if you do sine squared plus cosine squared, the Pythagorean theorem should give you the hypotenuse squared, which is just going to be 1. Okay, so that's where that one comes from. And then the other ones are the reciprocal identities that we've effectively learned this year. That cosecant is the reciprocal of sine, secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent, which could also be expressed as cosine over sine. So over these next 2 lessons, we're going to learn and review what we can accomplish with these identities, what we can do. In this lesson in particular, the skill that we're going to be developing is how can we find one trig function if we're given another one. So if I tell you what the sine of an angle is, can you tell me what the tangent is? If I tell you what the cotangent is, can you tell me what the secant is? And we're going to do all of that by using trigonometric identities. So that's our goal today. That's the thing that you're going to have learned by the end of this lesson. Here we'll take a look at an example. Suppose that we're given that the sine of some angle, some unknown angle, is 1/3. So you're being given one trig ratio. And then you're given some sort of restriction on the angle. They're saying, the angle that we're looking at has to be between pi over 2 and pi. And they're asking you to find the value of cosine. So the idea in this problem is, can we find an identity, a trig identity, something that allows us to relate the sine of an angle and the cosine of an angle? And so if you sort of look back at your guided notes or remember what you know of trigonometry or look at your IB math formula book, you should note that the Pythagorean identity does this. We know that sine squared x plus cosine squared x equals 1. Okay? So I have this thing. The question is asking me to find the value of cosine. We already know the value of sine, and so now I'm just going to plug that in. If I know that sine is 1/3, it means I have 1/3 squared plus cosine squared x equals 1. And now I proceed to solve for cosine, right? And this now becomes really similar to the previous lesson that we had about how to solve sort of advanced trig equations. Fortunately, we're not being asked to find x, we're just being asked to find the value of cosine x. So I'm going to have cosine squared x. This thing over here becomes 1/9, and so when I subtract that over, I'll have equals 8/9. Okay. Now again, they're asking me to find cosine x, not cosine squared, so I will square root both sides. And when I do that, I'm going to get cosine x equals plus or minus. The square root of 8 becomes 2 root 2, and the denominator is 3. So now the last thing we need to do here is we sort of need to ask ourselves, are both of these answers valid? Is it okay that cosine x is negative 2 root 2 over 3 and also positive 2 root 2 over 3? And for that, we need to look back at our restriction. Between pi over 2 and pi, what do we know about cosine? Like, think about the unit circle for a moment, right? Where is pi over 2 to pi? That's in the second quadrant. What do we know about cosine in the second quadrant? If you need to pause, think about that for a moment. Don't we know that in that quadrant, cosine is negative? That means that the cosine there has to be this. It can't be this. And as always, we should sort of provide a written justification. Like, why do we know that? And so, we write something like, on a given interval, cosine must be negative, or between pi over 2 and pi, cosine must be negative. So now that we've arrived at the end of this problem, I want to point out that our guiding principle on these problems is to find or to create an identity that relates the two trig identities that you're working with, and then plug in the value you have and solve for the one that you need. This problem was fairly easy because we already had an identity that directly related those two things. When we don't have that thing, we have to work a little bit harder, and so we're going to look at that next. So in this next example, you're given that the tangent of an angle is 4, and you're asked to find the value of cosine if the angle is between negative pi and 0. So we mentioned in our guiding principle that ideally we want some identity that relates tangent and cosine, right? Now, if we think about our options, we know that the tangent of x is equal to the sine of x over the cosine of x. And this comes close. Unfortunately, this doesn't directly relate tangent and cosine. Sine's kind of in the way too. So then I start thinking to myself, remember, wishful thinking is good in math. I wish I had some way to get rid of sine and turn it into cosine. Right, so now we sort of look back at our trig identities again, and we recognize, we do have that thing that says sine squared x plus cosine squared x equals 1. And this would help. If I moved the cosine squared over, I'd have sine squared x equals 1 minus cosine squared x. And that's good, but it's not perfect. I could square root both sides, but square roots are kind of ugly. So I kind of want to go back up here and think, maybe instead of square rooting this, maybe we just come up here and square both sides of this. If I did that, I would have tangent squared x equals sine squared x over cosine squared x. And now, without any squared ugliness at all, I can take this thing, which remember is an identity. This is identical to sine squared x, and I can replace that up here, right? This would sort of give me this new identity, tangent squared x equals 1 minus cosine squared x over cosine squared x. And now I basically have that thing that I wanted, something that relates tangent x and cosine x. So now if I just take this value of 4 for tangent and plug it in, I'm going to wind up with 16 equals 1 minus cosine squared x over cosine squared x. And at this point, we're pretty close. I really just need to work through and solve for this thing, right? I need to solve for cosine x. So I'm going to multiply my cosine squared x over. This is 16 cosine squared x equals 1 minus cosine squared x. Let's see here now. I've got 16 cosine squared x here and negative cosine squared x here. I could just add that 1 cosine squared x over. That would give me 17 cosine squared x equals 1. I could divide the 17. Cosine squared x is 1/17. And then just like last time when I square root, I'll wind up with cosine squared x equals plus or minus the square root of 1/17. And then just like we did before, we need to go back and look at the bounds that I was working with here. And what's interesting, if we again think about our unit circle, is that if I'm looking at angles between 0, and negative pi. So between negative pi and 0. In these two quadrants, cosine is positive over here, and cosine is negative over here. So it feels like both of these values are permissible, but there's a little bit of a catch here, right? I don't know if you thought about this, but think about the values of tangent. What do we know about the values of tangent in this quadrant, in the fourth quadrant? Down here, tangent values are always negative. And over here, tangent values are always positive. So it's a little bit strange. The problem told us that tangent had to be positive, which actually means the fourth quadrant was never even a possibility. This angle that we were looking at had to have been in the third quadrant, which means that the cosine value that we found has to be negative. The positive cosine value can't possibly happen because the assumption that tangent was positive couldn't have happened over there. So because of that, we know that our answer here has to be that, I'm sorry, I just realized this has had a squared here all along, has to be that cosine x here is negative square root of 1/17. I'll be honest, I don't know that I be asked the question this way super often, where you have to go back and also look at the original piece of information, but I wanted to make sure I covered it. It's a valid question and something that we need to be prepared for. So I hope that those two previous examples made sense. I would really encourage you, if you haven't done one of these on your own yet, try this one on your own. The next example is going to be a little bit different, so this is sort of an opportunity for you to try out what you've learned on your own. So given that, they give us a sine value and they want to know the tangent value. So just like we did last time, we're going to look at something that relates the two of them. We know that tangent x is sine x over cosine x. I'm really kind of wishing that cosine down there wasn't a cosine. So I remember that sine squared x plus cosine squared x is 1. And cosine was the thing I wanted to get rid of. So this time I'm going to rewrite this thing in terms of get cosine squared alone. I go back up here and I square both sides of this thing so that I've got a nice easy way to plug in my cosine squared. I'm now going to replace the denominator with 1 minus sine squared. So the identity that I've come up with is tangent squared x equals sine squared x over 1 minus sine squared x. Okay? At this point, I need to take the information that I was given and put it into the problem. Right? We were told here that sine x was negative 2/3. So when I plug this thing in and square it, I'm going to wind up with 4/9. So tangent squared x is 4/9 in the numerator. In the denominator, I have 1 minus 4/9. All right, so that means I've got 4/9 in the numerator, 5/9 in the denominator. The ninths are going to drop out here, and so I'm left with tangent squared x is 4/5. And then we square root both sides. This time I'm going to square root the two of them independently of one another because I can see that the 4 is going to drop out. I'm going to get tangent x, I suppose I should have my plus or minus so I don't forget. Tangent x is plus or minus 2 over root 5. If you feel better about it, you can write that as 2 root 5 over 5. IB doesn't really care about whether you rationalize the denominator unless they sort of specify. Once again, I have two answers here, and so we do need to go back and look at the information that was given. We were told that our angle here needed to be between negative pi over 2 and positive pi over 2. So our angles are here. And now we look at what we know, right? In the first quadrant, we know that tangent is positive, and we also know that sine is positive. So that's actually interesting. We were told in the problem that sine was negative, which means this can't be where it happened. In the fourth quadrant down here, sine is negative, which is good. That checks out with what we were given in the problem. And down here, we know that tangent also has to be negative, basically because the cosine is positive. And so this is sort of the one quadrant where this is going to work. It means that our tangent has to be negative. That allows us to conclude that the tangent of this angle has to be negative 2 root 5 over 5. So again, hopefully that made sense. This is sort of the process that we use to find one trig identity given another one. I mentioned at the beginning of the previous example that The other examples we were going to have in this video are going to be a little bit different. They're not really a ton different. I just want to point out to you that sometimes we're going to have reciprocal functions to deal with. You might need to deal with this with cosecants or with secants or with cotangents. And I want to point out there are trig identities that relate those reciprocal functions. You are totally welcome to use them, and it's valuable to know them. But it's totally possible to solve them by looking at their reciprocal counterparts instead. Right? Instead of trying to make this problem all about the reciprocal functions, couldn't we take this one right here and go, wait a minute, I know I want to get cosine, but I know an identity that's directly related to cosecant. Cosecant is 1 over sine x. And then I might look at it and go, yeah, wait a minute, I actually know a trig identity that relates cosine and sine. Man, I really wish this was just a plain sine and not 1 over sine. Well, great. Choose to reciprocate this thing that you were given. We can take this and say sine x then has to be 3/5. Now that you know that that's 3/5, it should actually be pretty straightforward for you to go and find out what cosine is. So pause the video and make sure that you can work through this one on your own. It should be pretty straightforward at this point. The thing that we have that relates sine and cosine is sine squared x plus cosine squared x equals 0. Right? I'm sorry, not equals 0, equals 1. Don't know where that came from. Great, now I plug this 3/5 in where I'm told. This gives me 9/25 plus cosine squared x equals 1. That means cosine squared x is 16/25. We square root both sides and get that cosine x needs to be plus or minus 4/5. And the last thing we do, remember, we look at this interval and we need to make a statement about whether this answer is going to be positive or negative. So if you haven't done that part, make sure that you sort of practice writing down what the real answer is or what multiple answers are and give your justification for that. So in this case, we're going to say that the cosine of x has to be positive 4/5 because in the first quadrant, cosine is always positive. So please remember that your answer is not just the cosine x equals 4/5, but also the justification for why we decided to leave out the negative value of the cosine that we just found. So let's take a look at this last example now. I would encourage you guys to try and do this one on your own. If you're feeling uneasy, I'll give a hint here in just a moment, but I'd encourage you to sort of pause the problem and think through what you know about reciprocal trig functions and what you think your strategy should be here. After you sort of thought about that strategy and what trig functions you want to be working with, go ahead and listen in on a hint of mine if you'd like. So I think my thought here is these things are both reciprocal trig functions. I would really rather think of this as 1 over tangent x equals negative 3/5, and then say, yeah, let's do this in terms of tangent x. Tangent x is negative 5/3. And then I sort of tell myself, cosecant is 1 over sine x. If I could just find sine x, I could just take that thing and reciprocate it to figure out what cosecant x is. So this problem doesn't really need to be about cotangent and cosecant. It can really be about tangent and sine, and I just remember to reciprocate at the end. That's kind of what my strategy is going to be. Now that you've sort of got that sense of strategy, make sure that you give yourself a chance to try this problem on your own. We've done something similar to this a few times now, so I'm gonna try and move through this kind of quickly. Remember, we know that tangent x is sine x over cosine x. We want to replace this cosine x. So we've noted before that cosine squared x is 1 minus sine squared x. So then I'm gonna sort of skip some steps here. I'm gonna square this thing and I'm gonna plug this into the denominator. We know that tangent squared x is sine squared x over 1 minus sine squared x. At this point, I can plug this negative 5/3 in here. That gives me 25/9 equals sine squared x over 1 minus sine squared x. In this case, I'm going to sort of like cross multiply here. I'm going to move the denominator up with a 25, move this 9 up with here. This gets me 25 minus 25 sine squared x equals 9 sine squared x. Then I'm going to take this negative 25 sine squared x and move it over. 25 equals 34 sine squared x. From there, if I divide the 34 over, 25 over 34 equals sine squared x. Square rooting both sides gets me this idea that the sine of x is plus or minus 5 over root 34. And the last thing I need to do is I need to look at my interval. My interval was between 0 and pi, and we were given that cotangent was negative. So between 0 and pi, so I'm looking at this, right? So since I'm looking up here, in both of these quadrants, sine has to be positive. So in some sense, my answer here has to be the positive 5 over root 34, right? And so because that thing has to be positive 5 over 34, we can sort of conclude in the end, remember our question wasn't really about sine, they were asking for cosecant, we can state that the cosecant of x has to be root 34 over 5. Remember, it is still necessary that we write something like, because we're in the first and second quadrants, our sine or our cosecant value needs to be positive. And that's the end of our lesson for today. I hope that made sense in terms of how to use trig identities. The practice that we're doing today is really going to support what we're doing tomorrow. So hopefully you make sense of this. And please be sure to ask me questions if you've got them. Best of luck.